In this tutorial session, let's talk about exception handling. The purpose of handling an exception is to locate an error, handle the error, then continue running our program. Up to this point, our program stops running when it encounters an error. In the IDE, let's start with a variable called number. Then prompt input from the user. 100 divided by number. Enter a number. We want a value after dividing 100 by a number. Next, let's print the value. Also, tell the user, thanks for your input. One more thing. Let's also take the number and convert the number to an integer by writing the int function. When I run, enter a number, how about 10? The console returns 10 and thanks for your input. This time, watch what happens when I enter TEN. We get a traceback. A traceback includes information about the exception. The exception is a value error. I enter 10, which is a string, but the program expects an integer. That's why the console shows invalid literal for int. Notice two things. Number one, both print statements did not show up. And number two, the exit code is 1. 1 means there is a problem. We do not see the print statements because the program stopped running after the input function. Enter a number. In the program, the print statements on lines 4 and 5 should print the value, then print thanks for your input. However, the program returned an exception because we did not handle the exception. We handled exceptions in Python by using try except blocks. A try except block has two concepts. First, it asks Python to do something. Then it tells Python to do something. Ask, then tell. First, it asks Python to try and execute our code. Then tell Python to raise an exception if there is a problem with our code. For example, we want to try and execute the first 3 lines. Get input from the user. Divide 100 by a number, then print the value. To perform the first concept, we write try and a colon before the 3 lines. Then indent the 3 lines. For the second concept, we use the keyword concept. Keyword except, except. And don't forget the colon after the 3 line. Now we want to perform a command. Let's just add a print statement with the message that says invalid number. Notice there are 3 print statements. 2 of the print statements are indented and 1 of the print statements is not indented. For the first indented print statement, it's a part of the try clause. The second indented print statement is part of the except clause. And the third print statement is not indented. It's the last print statement and it's not part of no clause, but it will execute each time. It shows how execution continues running after coming across an exception for an invalid number, and it shows what happens when not coming across an invalid number. Try except blocks are good for recovering from an exception that we anticipate to happen. If there is not an error, then Python skips the exception clause. So when I run and enter 10 again, we see 10 and thanks for your input. But when I run and enter the same string, TEN, the console shows us invalid number. Also, the print statement, thanks for your input, although there was an exception. We cannot divide 100 by TEN. Exit code shows 0. Do you see the line under except? That's too broad. So the message says too broad exception clause. Python prefers a detailed exception handler like the value error, and the line goes away when I enter value error. Now, after the exception, we see the line goes away, but also we can make the print statement more detailed by adding invalid number, enter a numerical value. So now when I run and enter a string like ONE, the console shows invalid number, enter a numerical value. The message provides more detail and lets the user know what to do. What if by mistake a user they want to enter 20 but forget the 2, so they only have 0 as their number? We see a different traceback. 0 division error is the exception. It shows up because a number cannot be divided by 0. The previous exception for value error did not match 0 division error, so the program stopped running. If I hover except, we see the except clauses specify one or more exception handlers. Therefore, we can add one more except clause for 0 division error. In fact, we can add many exceptions as we need to. So before the last print statement, we write except 0 division error. It's optional, but we can also add a variable after the exception name as EX. It can also be EXC because it's a variable, so it doesn't matter what we name this EXC. Don't forget the colon. Let's print EXC. Now, EXC will return division by 0 if there is an error. Let's also add another print statement so it's more detailed. Print invalid number. Number cannot be 0. If there is not an error with the code inside the try block, then Python skips over each except block. Now, if there is an error, then Python look for an except block that matches the error, then execute the code. Let's run, and number is 0. The console shows division by 0, which comes from the variable EXC. Invalid number cannot be 0 is our customized message. Enter another number like TWO2. We see a different message, invalid number, enter a numerical value. We see how the try except block handled exceptions. If we enter a good number like 5, then we see 20, and the print statement, thanks for your input, which prints every time when handling an exception. That's it for handling an exception using Python try except block. Thanks for watching, and I will see you in the next session.